You know, every single time you check your bank balance or book a flight or even just stream a movie, you're using a technology that was born way back in the 1970s. It's kind of like this invisible backbone of our entire digital world, the one universal language for talking to data, and that language is SQL. So, let's dive into the incredible story of how this half-century-old technology ended up running, well, pretty much everything.
I mean, it's a huge question, right? For the world to actually run on data, we need a way to manage it all. We need to be able to ask it questions and get reliable answers back no matter what kind of computer or system we're using. And that, right there, is the problem SQL was created to solve, to give us a single, powerful, and understandable way to communicate with these just massive, ever-growing mountains of information.
So for this explainer, we're going to walk through the 4 key chapters in the story of SQL. We'll start with the revolutionary idea that kicked the whole thing off, then we'll get into the frantic race to sell it, see how it became the official standard, and finally, we'll look at how it's still changing even today.
Okay, let's go right back to the beginning. Because before you can have a language for data, someone had to completely rethink how we even store it in the first place. And this wasn't just some small update. It was a total paradigm shift that laid the groundwork for everything that came after.
And this right here, this is the Big Bang moment. In 1970, an IBM researcher named Edgar F. Codd published this paper, A Relational Model of Data for Large Shared Databanks. Now, I know, the title doesn't exactly scream excitement, but trust me, this paper was the spark that lit the fuse for the entire relational database revolution.
So what was Codd's big idea? Well, it was actually beautiful in its simplicity. See, before him, data was stored in these complex, tree-like structures that were a total nightmare to navigate. Codd proposed something much cleaner. Just organize everything into simple tables, what he called relations, made up of rows and columns. Then you could link these tables together. This elegant model just made managing and asking questions of huge amounts of data infinitely easier. Now, an academic paper is one thing, but turning it into a product you can actually sell, that's a whole other story. Codd's idea kicked off this incredible race, pitting the slow-moving research giant that came up with the idea against a tiny, scrappy startup that saw its billion-dollar potential.
So of course, IBM was the first one to act on it. In 1974, a team there built a prototype called System R, just to prove Codd's theory could work. And to talk to their new database, they invented a language they called SQL, which stood for Structured English Query Language. The goal was to make it feel really intuitive, almost like you were just asking a question in plain English.
And here's where the story takes a fascinating turn. While IBM proved the concept with System R, they pretty much just treated it as a cool research project. But on the other side of the country, a few guys named Larry Ellison, Bob Miner, and Ed Oates read about System R and saw a massive business opportunity. They went and founded a startup called Relational Software, which you probably know by its later name, Oracle. And here's a great little piece of trivia for you. Why don't we call it SQL today? Well, it turns out that name was already trademarked by a British aircraft company, of all things. So they just dropped the vowels, and the name SQL was born, a tiny change that obviously stuck around. So while IBM was still tinkering away in the lab, Relational Software, soon to be Oracle, rushed the first ever commercial SQL database to market in 1979. And in an absolutely brilliant marketing move, they didn't call their first release version 1. Nope, they called it Oracle version 2, which made potential customers feel like they were buying a mature, stable product, not some risky first attempt. Genius, right? With Oracle's success, and IBM finally releasing its own products like DB2, the market suddenly got crowded. It created this kind of Wild West scenario where everyone had their own version. For this technology to really take off, everyone needed to agree on a single, common language. It was time to create a standard. And that's exactly what happened. In 1986, the American National Standards Institute, or ANSI, made SQL an official U.S. standard. The very next year, the International Organization for Standardization, ISO, made it a global standard. This was huge. It basically cemented SQL as the official language of databases everywhere. And it was followed by major updates like SQL 92 and SQL 1999 that added all sorts of powerful new features.
But as the language got more powerful, it also got way more complex.
I mean, just look at this. The first standard in '89 was a pretty manageable 150 pages. Just 3 years later, SQL 92 ballooned to over 500 pages. And by 1999, the official standard was a whopping 2,000 pages long. This growth showed how important the language was becoming, but it also created a brand new problem.
And the thing is, no single database company implements every single feature from that massive 2,000-page rulebook. It's just too much. Instead, what they all do is support the core, standard SQL, but then they add their own special functions and extensions on top. And that is why we have different dialects of SQL, like Oracle's PLSQL or Microsoft's T-SQL. They're all SQL at heart, but with their own unique flavor.
So that brings us to today. And it's easy to look at a 50-year-old technology and think, wow, that's a dinosaur. But the real story of SQL is one of constant adaptation. It hasn't just survived all this time, it has absolutely thrived by evolving to meet the demands of a totally different digital world.
Yeah, far from being some dusty old relic, the SQL standard is a living, breathing document. There are committees constantly working on it, and major updates are released every few years. The SQL 2016 standard is a perfect example of this, showing just how committed the community is to keeping the language sharp and relevant.
I mean, just look at the 2016 update. The biggest new feature, by far, was native support for JSON data. This was a massive deal. It was a direct response to the rise of NoSQL databases and all the web APIs that use JSON. It basically allowed the traditional structured world of SQL to play nicely with the messy, semi-structured data that really powers the modern internet.
And ultimately, I think this is why SQL has lasted so long. Its whole design, the fact that you just say what data you want, not how to get it, makes it accessible to everybody, from hardcore developers to business analysts who just need to run a report. It's a true bridge technology, letting entire companies speak the language of data and make smarter decisions. So, after this half-century journey from a research paper to the engine of the global economy, SQL is more important than ever. It has outlasted countless other technologies because it's powerful, it's simple, and it's incredibly adaptable. Which really just leaves us with one final thought. What new challenges will it evolve to solve in the next 50 years?